Hey guys, how are you? I hope you guys are doing well. Had a good weekend. We're going to transition into part two for our systems of equations. We're going to start talking about how to find the solution to a system algebraically. So if we recall from last week, the solution to a system is where our two lines cross. So we graph both lines, we find that point of intersection. But we're going to talk about how we can do that algebraically. Before we do that, I want to just review briefly graphing a system. And then we're going to come back to these two equations later on. So if we share screen here, you're going to see right now on the screen two equations, y equals negative 2x minus 10 and y equals x minus 7. Now, both of these are already in mx plus b form, so they should be relatively straightforward to graph and find the solution. So let's go ahead and graph these two equations. I'm going to start with the first one here. Now, the first one actually is going to give us an idea about graphing something that is going to fall off the grid. So if we start with our y-intercept of negative 10, I'm going to plot a point down here at negative 10. Now, our slope is negative 2 over 1, which means down 2 to the right 1, but this falls off the grid. So this is a great example of how we can use the slope in the other direction to get points. So instead of going down and to the right, let's go up and to the left. So we're going to go up 2, back 1, up 2, back 1. We're using the negative in the bottom of the fraction now for each of these. Because you don't always have to use the negative to go down and to the right. We could go up and then back. So we're going to graph that first line, and we've got a second line now of y-intercept at negative 7. Negative 7. And then for our negative 7, we're going to go ahead and say we're going to go up 1 over 1. 1 over 1. And we'll go ahead and graph that one there. And if we look at our answer there, we're going to go ahead and say, okay, our point of intersection is right here. And so the solution to this system is negative 1, comma, negative 8. And so we've got negative 1, negative 8 for our solution to that system. So again, a review of graphing. What we're going to look at now is we're going to transition into how can we find these solutions algebraically. Now, there's two methods to do that. The first method is going to be what we call a substitution method. And that substitution method, let's go ahead and stop sharing screen here. That substitution method is literally that. You're going to substitute into the equation to find our solution. Now, we're going to start very basic, and then I'll give you some notes that will allow us to do some of the more complex ones. Some of you have already identified early on how we can actually do this. Some of you saw this in class, which was actually really cool last week. So let's go ahead and start off here with a very basic of our systems. So let's go ahead and go back to share screen. So our first problem here says solve using substitution, and then it gives you an equation, negative 2x plus 3y equals 5. And the second equation is y equals 5. Now, the first two examples are really basic and simple because I'm going to give you half of the answer. If you understand and recognize that the solution to a system is an ordered pair, half of that answer has already been given to us. The second equation already tells us that y equals 5. So for my ordered pair, I'm going to put 5 into the solution already. Now, if I want to go ahead and solve the system using substitution, I know that y equals 5. So I am going to substitute that into the other equation where I see the letter y. So negative 2x plus 3y equals 5 is going to become negative 2x plus 3 times 5 equals 5. I substitute the value of y into the other equation, and now I'll solve. So negative 2x plus 15 equals 5. Subtract the 15, and negative 2x equals negative 10. Divide, and x equals 5. So the solution to this system then is 5, 5. What that means is if I was to graph the y equals, which is a horizontal line, and I was to graph the first one by getting it into mx plus b, they would cross at 5, 5. Now, if you were to get this one into mx plus b, for those of you who can do that mentally, it's going to be a challenging equation to graph. And this is why we need to have an algebraic method to solve. So we already were given the y value. I found the x value, and now I know the solution to the system. So let's take a look at another example then using that same principle. This second example gives me the x value for this system. So I already know that the x value is 2. So if I start my ordered pair, it's going to be 2, something. And I need to find the y value. So I'm going to take this value of 2, and I'm going to substitute it in for the letter x. And when I do that, I'm going to get negative 6 times 2 plus 3y equals negative 3. So it gave me the x value, and we're going to substitute in to find the y value. So let's go ahead and solve. Negative 12 plus 3y equals negative 3. Add 12. Add 12. 3y equals 9. So y equals 3. I'm going to take that and I'm going to put it up here for the ordered pair because that's the y value. And that tells me that the solution to the system is 2, 3. And if I was to graph both lines, that would be the point of intersection. So substitution, substitute what you have into the equation to solve. What happens, however, if these are more complex? So let's take a look then at the notes for this particular section. I have uploaded 2 different sets of notes for substitution. This is the set of notes for all problems, no matter how complex. There's another screen of notes that you can look at, and those are for ones that are going to be in MX plus B. And those are going to be very common on the standardized test. For your notes here, and if you guys want to go ahead and pause at the end, you can, so if it doesn't catch up. To solve a system using substitution, the first step is get one variable alone in one of the equations. That means get x alone or y alone in either the first or the second. Now, a lot of times it's going to be very obvious to you, or it's already going to be done for you. In a majority of problems where you would use substitution, this has already been done. But you might have to work a little bit to make this happen. So one of our examples will make you go through the whole process. Once you get one variable alone in one of the equations, you're going to substitute, there's that key word. You're going to substitute the expression from step 1 into the other equation for that variable. And this is the key. You have to substitute it into the other equation. You cannot substitute it back into itself. You're going to run into a problem if that happens. You're going to solve the equation for that variable. Whatever answer you get is then going to look just like what we had here. You're going to get y equals 5 or x equals 2. You're going to have some solution for a variable. Substitute that answer into either one of the equations from the beginning, and then solve to get the ordered pair. And as soon as you start seeing examples, this will make sense. Right now, it's obviously just a bunch of steps and words. So if you need to pause right now, go ahead and pause it so you can finish copying down the notes. We're going to go ahead and move on to our first example. And our first example should look familiar to you. Y equals negative 2x minus 10, y equals x minus 7. This was the example we used at the very beginning when we graphed. So if we go back to the example at the beginning, We already graphed this, and we already know that the solution is supposed to be -1, -8. So now let's do it algebraically. If we go through our steps, step 1 said get one of the variables alone in one of the equations. Well, I already have y alone in the first equation, and it actually got y alone in the second equation. So this has already been done for us. Now, what I'm going to do is I'm going to take this expression, -2x minus 10, and that expression is what y equals. So I am going to take this expression and I am going to substitute it into the other equation for where I see the letter y. So the letter y is going to get replaced with that expression. And that's what you're going to do. You're going to take an expression and you're going to substitute it into the other equation wherever you see the variable. So this letter y gets replaced with -2x minus 10 equals, and on the other side I have x minus 7. When the equations are both in mx plus b, this is the process you're going to do every time. I now have a multi-step equation. So we're going all the way back to September, and we're talking about multi-step equations. So I've got to move the 2x to the other side. So I go plus 2x, plus 2x. -10 equals 3x minus 7. Add 7. Minus 3 equals 3x. Divide. And x equals -1. I now have the x value for my system. And if I want to now find the y value, I take this -1, because that's what x equals, and I plug it back into either one of the originals. Now, I usually like to plug it into the one that I have the box around, because for substitution, that works out really nicely. So I'm now going to get y equals -2 times x, which gets replaced with this -1, minus 10. Y equals 2 negatives makes it a positive. Oops. I already jumped the gun and gave you the answer. And there's my y value of -8. And I got the exact same solution as if I had graphed them. So solving a system using substitution, if both of them are in mx plus b, you're going to take one expression and substitute it into the other equation. All right, let's go ahead and take a look here at one of the more complex types of problems then, using substitution. So if we go back to step 1, solve one variable, get one variable alone in one equation. Well, there is one obvious choice to get alone, and that is the x in the first equation. Getting the x alone in the first equation makes the most sense because it will take the least amount of work. So I'm going to over here. And to get the x alone, let's subtract the 6y. So x equals 19 minus 6y, not x. I have done step 1. I got one of the variables alone in one of the equations. I am now going to put a box around this expression. And I have to substitute that expression in for the letter x in the other equation. So this letter x right here is going to get replaced with that expression, because that's what x equals. X equals this expression. So I'm going to replace x with that. Now notice the -10 stays there. So that's going to be multiplication. So this becomes -10 times this expression. 19 minus 6y plus 2y equals -4. Solve for the letter y. So -10 times 19 is -190 plus 60y plus 2y equals -4. -190 plus 62y equals -4. Add 190 equals positive 186. And now I have to divide by 62. 186 divided by 62 is going to be 3. So my y value for this system is 3. So I'm going to take that, I'm going to put that up here. I know the y value for this system. Now, if I want to go ahead and finish and find the x value, I'm going to take this and I'm going to plug it in for the letter y. Now, like I said in the last example, I really like to use the one that I've put the box around because that one is nicely prepared for us. So this becomes x equals 19 minus 6 times y, and y is 3. So I'm going to substitute 3 in right there. X equals 19 minus 18. So x equals 1. And I now have the solution to the system. If I had graphed these using mx plus b, it would have been incredibly difficult to find the solution. So now we have an opportunity to use an algebraic method. I highly recommend to go back and watching this again if this was maybe a little confusing. It is understandable. Seeing it a couple times might be helpful. We will go through another method later in the week, and that's going to be elimination method. But substitution method for solving systems is going to be the first part of this week. So hopefully this was useful for you. You'll have an IXL assignment that goes along with this. And fortunately for you, most of those problems are going to be easier than the final example. Guys, take care. Have a great rest of your day.